Hello and welcome to week 3 in geometry. We are going to start with a warm-up, but before we do that, I wanted to remind you to make sure you've got your math notebook out. I do want you to be taking notes as you go through the recording this week. I will look for your notes when I grade your notes from week 3 that you submit at the end of the week. I'm going to look to see that you have notes from this recording. The reason I ask you to take notes is taking notes makes you more of an active learner as you are watching this recording versus just putting your feet up and watching the recording, which would make you more of a passive learner. You will get much more out of this if you are taking notes as the recording progresses. And remember, you've got that great opportunity of clicking that pause button so that you can take notes and then clicking play when you want to return back to the recording. So let's start with a warm-up question that I do want you to complete in your math notes. So I will look for the warm-up question when I grade your week 3 notes this week. Taking a look at the warm-up question. I'm going to add some things here to this figure before we get started. So I'm adding arrows onto the sides of this quadrilateral. What do those arrows mean? Before we jump into the warm-up, what do those arrows mean? So remember, it's important that we understand the symbols that we put on figures because they're giving us important information. In this case, if we have arrows, it means that the sides are parallel. So see how this side only has one arrow and this side over here also only has one arrow? That means that this side here is parallel to this side. This side has 2 arrows and this side also has 2 arrows. That means these 2 sides are parallel. So we have 2 sets of opposite sides that are parallel. So what kind of shape are we working with? If you said parallelogram, you are right. So I'm giving you some hints to get started here. So taking a look at this parallelogram, I want you to solve for y. I want you to solve for y. And remember, in order to solve this problem, we need to think back about the properties of parallelograms that you've learned so far. And one of those properties is going to help you set up an equation that will allow you to solve for y. So go ahead and click pause and try this on your own. And then when you are ready to check your work with mine, you will click play. All right, so what do we know about parallelograms that's going to help us solve this problem? We already talked about, one of the things we know is that opposite sides will be parallel. That's not going to help us solve this, not this problem. What else do we know about parallelograms? We know opposite sides are congruent. Opposite sides will have the same measurement. So opposite sides are going to be equal. This is going to allow us to set up an equation then. So since we're solving for y, we're really only going to focus on this side and this side. This side, the other 2 sides have x's. That's not going to help us solve for y. So because we know this is a parallelogram, we also know that opposite sides are congruent. So I can say then that 4y minus 3 must be equal to 2y plus 7. Now I've got a nice algebraic equation that I can solve for y in. So I'm going to work on getting all my y terms on one side of my equation and all the constants on the opposite side. So I'm going to move this 2y. I'm going to get the y's on the left side and move all the constants to the right side. So I'm going to move this 2y by subtracting 2y from both sides. And what do I left with? I'm left with 2y. 4y minus 2y is 2y. And I still have that negative 3 hanging out on the right side. My y's canceled out on the right side, and I'm left with just 7. So now I want to work on getting y all alone, so I'm going to move that 3, that negative 3. So to get rid of that and move it to the other side, I'm going to do the opposite of subtracting. I'm going to add that 3 to both sides. Now on the left side of the equation, I'm left with just a 2y. And set that equal to 7 plus 3 is 10. I'm one step away from solving 2y, so I got to divide each side by 2 to get y all alone. Y is going to be equal to 10 divided by 2, which is 5. So my final answer right here is that y is going to be equal to 5. And And the problem just asked me to solve for y. I always want to look back and make sure, did I solve what the question asked me to? It just asked me to solve for y. I did that down here, so we are done. Sometimes maybe a problem might say find a length of a side. Once you found a variable, then you can plug it in and find that length. But what I'm reminding you is to make sure that when you're done, you go back and reread what the question was asking and make sure that you answer all parts of that question. All right, I'm going to move on to the next slide. So if you need more time on this slide, go ahead and click pause. Maybe you need more time to take notes. If you do, click pause. All right, so what are we looking at this week? We are going to complete Unit 5, Session 5, Unit 5, Session 6, and Unit 5, Session 7. The first session, we're going to look at conditions for parallelograms, looking at solving problems that involve coordinate planes, and then we're going to move on to session 6 and 7 where we're going to learn about some special types of parallelograms. So we're going to look at rectangles, squares, and rhombus, so special types of parallelograms, and what are the properties of those. And you will know a little bit about those by the end of this recording. So let's jump right in. Let's review some properties of parallelograms that we've learned about. Because the special types of parallelograms, squares, rectangles, rhombus, those are types of parallelograms. So when we learn about those special types of parallelograms, when we learn about squares, rectangles, and rhombus, they will have all of the properties of parallelograms and then some specific properties that make them a square or make them a rectangle or make them a rhombus. But all those quadrilaterals I just mentioned will all have the properties of parallelograms. So I did want to review what are all the properties of parallelograms that we've learned about. So first of all, parallelograms are always quadrilaterals. They're going to have 4 sides. Parallelograms are always going to have 2 sets of parallel sides. Again, pay attention to the notation. They're arrows. Arrows on the sides mean that the sides are parallel. Let's go right under there with the ticks. Remember when we have ticks on our sides, what that means? Well, in order to be a parallelogram, opposite sides are congruent. So the same number of ticks lets us know that those sides are congruent. What about angles? What did we learn about angles of parallelograms? Opposite angles are going to be congruent. So if we have a parallelogram, the opposite angles will be congruent. Note there's one arc here and one arc here. That means these 2 angles are congruent. This angle has 2 arcs. That means these 2 would not have the same measurement, but any arc that also has 2 arcs would be congruent. We also learned that if we draw on the diagonal, so if we go from one vertex to the opposite vertex, that's a diagonal, that line that connects those vertex. So if we have 2 sets of diagonals drawn into our parallelogram, those diagonals are going to bisect each other. So remember when we say bisect, that means that it cuts a segment into 2 equal parts. So you can see that the segment from here to here would be congruent from the segment from here to here. And same with the other diagonal. And then last but not least, we learned that parallelograms will have adjacent angles that are supplementary. All right, so I'm going to move on to the next slide. All right, so let's take a look at a problem. This problem is pulling from the concepts that you're going to learn from Unit 5, Session 5. So just a heads up for that. So we are trying to determine if a quadrilateral is a parallelogram. So in this problem, we are given vertices of a quadrilateral. We're given 4 vertices, and we want to determine if that 4-sided figure is a parallelogram. So how are we going to do that? Well, let's start with first plotting our points. That's a good place to start. So we're given 4 vertices. Let's plot those points. The first one is A is at -3, 2. So let's plot that, mark it with an A. That's point A. B is at 2, 2. We're going to plot that and mark it as a B. C is at -5, -1. I'm going to plot that point. C, and then our last point D that we're plotting is at 0, -1. So looking at these vertices, we can connect our points. So let's go ahead and connect those. I'm going to do the best I can to do them as straight as I can. It's not super easy all the time with the tool I'm using. So looking at this, it looks like it might be a parallelogram, but we can never assume anything in geometry. We always have to back up our reasoning with full proof, concrete reasonings. We want to have something that we can prove that this is a parallelogram. So what can that something be? Well, didn't we learn a lot of properties about parallelograms? We did, and we just reviewed all those. So let's use one of our properties to prove this is in fact a parallelogram. So what do we know about the sides of parallelograms? We know that opposite sides are congruent. So one thing that you could do is find the distance between your two sets of opposite sides. And we can use the distance formula. That's kind of a lot of work because we would have to find the distance from A to C, the distance from B to D, make sure those are same, and then find the distance from A to B and C to D and make sure those are same. That's a lot of plugging information into the distance formula. However, you can do it because that is one of the properties, and if you are able to prove the opposite sides are congruent, you've proved it's a parallelogram. What is another thing we know about parallelograms? We know that opposite sides are parallel. And this one is what I'm going to use to take a look at this. So opposite sides of parallelograms are parallel. And what do we know what do we know about the slopes of opposite sides? We learned this back at the beginning of Unit 5. We did some review from algebra. Parallel lines will have the exact same slope. They'll have the same rise over run. So we can figure out the slope of both of our lines, our opposite sides. So let's first focus on, let's do a darker color here. This side here, AC, and the side opposite of it, BD. What are the slopes of both of those sides? So let's start with side AC. What is the slope of side AC? So remember, slope is rise over run. Not sure why my screen keeps zooming like that. I apologize for that. I'm trying to catch it. So slope is rise over run. So let's go from this point C and see how many units up and to the right we go to get our slope from C to A. So to go to C to A, I rise 1, 2, 3. So I'm going to have my numerator is going to be 3 for my slope, and then I have to go to the right 2 places. So from C to A, that line has a slope of 3/2. Now, if this is a parallelogram, we need to have that same slope when we go from D to B. So let's check it. So from D to B, we go rise 1, 2, 3, and then we go to the right 1, 2. So it also has a slope of 3/2. That is a good thing. Now we need to look at the slope between A to B and C to D. And we have a horizontal line for both those, don't we? Our two sets of remaining opposite sides are horizontal lines. What do we know about the slope of horizontal lines? If you want, you can do a quick web search, but the slopes are 0. And since we have two sets of horizontal lines, we've got from A to B, this is horizontal and this one is also, we've got a slope of 0. So what does that tell us about both of our sides, our opposite sides here? Both pairs of opposite sides have the same slope. So because both sides, opposite sides, have the same slope, we know that this is in fact a parallelogram. We've proven it. We didn't just look at the four-sided figure and say, it looks like a parallelogram. We took it a step further and we used the slopes to verify that it is in fact a parallelogram. All right, so moving on to special parallelograms. So I introduced in the beginning of this recording a little bit about the special parallelograms that we are going to learn about. So let's take a step back. So Unit 5 so far is all about quadrilaterals, right? Everything that we've looked at so far has 4 sides. So everything that we've looked at so far is a quadrilateral. So parallelograms have 4 sides. So a parallelogram is technically a quadrilateral, right? Because a quadrilateral just has to have 4 sides. A parallelogram has 4 sides. So a parallelogram is a quadrilateral. It's just a special type of quadrilateral that has all those special properties that we've talked about and reviewed in this recording. Well, now I'm about to introduce to you some special types of parallelograms. So just like a parallelogram is a quadrilateral, these 3 special types of quadrilaterals I'm about to introduce to you are parallelograms. So what are those special parallelograms? They are rhombuses, squares, and rectangles. So squares, rectangles, and and rhombuses are parallelograms. So that's what I wanted to show you with this chart, is that all 3 of these special types of parallelograms, they are parallelograms, which means they will all have the properties of parallelograms and then some properties that make them specific to their shape. And we're going to talk about what those are. But I did want to show you this chart. So rhombuses are parallelograms. Rectangles are parallelograms. Squares, they're even more special. So not only are squares parallelograms, but a square has all the properties of a rectangle, and it also has all the properties of a rhombus. And we're going to go over what those properties are right now. But I just wanted to show you this flow chart that explains what each quadrilateral, how it can also be the one in front of it. So let's go on to the next slide. Here we go. So let's talk about all the properties of all of our new special types of parallelograms that I just introduced on the previous slide. So keep in mind, this is a cool chart because it's kind of like a hierarchy of special parallelograms and their properties. So keep in mind that all special parallelograms have all the properties of parallelograms that we've talked about. But what makes these other guys special? So rhombuses have all the properties of a parallelogram, and then more specifically, their diagonals, the diagonals of rhombuses, are going to be perpendicular. They're going to intersect at 90 degrees. That's what makes that special, is that the rhombuses are a little different from parallelograms, or special. It's a special type because the diagonals are perpendicular. So the diagonals will intersect at a 90-degree angles, and the diagonals will bisect the opposite angles. So these angles right here, the diagonals will bisect those, so that from here to here we'll have the same measurement from here to here. What about a rectangle? So a rectangle, again, has all 4 properties of a parallelogram, and then its diagonals are going to be congruent. So the length from here to here is going to be the same length as from here to here. That's what sets a rectangle apart from just being a parallelogram. And then squares have all the properties of parallelograms. They have all the properties of rhombuses, and they have all the properties of rectangles. And then to be a square, squares are going to have equal angulars, or equiangular. A square meaning all angles are going to be right angles, and then all sides will be congruent. So equiangular means all angles are congruent, equilateral means all sides are congruent. So technically, a square can be considered a rectangle because a square has all the properties of a rectangle. A square can also be considered a rhombus because a square has all the properties of a rhombus. And then a square is a type of a parallelogram because it has all the properties of a parallelogram. Opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, and the diagonals bisect each other. So technically, a square is a rhombus, a square is a rectangle, and a square is a parallelogram. A rhombus is technically a parallelogram, and a rectangle is a parallelogram. Again, keep in mind as to what the properties are. So you'll have some lessons this week that state all the properties of these special types of parallelograms. But what I really want you to take away is how a square is also a rhombus. A square is a rhombus because it has all the properties of a rhombus. And same with the rectangle. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. All right, so now that we have been introduced to the properties of some of our, or of all of our special, some of our special right parallelograms, such as the rectangle, let's see if we can solve a problem that involves one of our special types of parallelograms, which is the rectangle. So this is a rectangle. We are given that information. It is stating this is a rectangle, pictured below. And we're given some information. We're given some side lengths. We know that from M to L is 10, and we know from L to O is 24. And we know that NL, so one of our, the length of our diagonal there, let's get that in, is 26. So the length from N to L, that's our diagonal, is 26. And we want to find the length of MO. We want to find the length of our other diagonal, and MZ, so half of our diagonal. So what are the properties of rectangles? So since we're told that we have a rectangle, and we're dealing with the diagonals, so really let's hone in on the properties of diagonals of rhombuses. So what are the properties of our diagonals of rhombuses? I think I just said rhombus. I meant to say rectangle. If I said rhombus, replace rhombus with rectangle. I meant to be saying rectangle that whole time. So the rectangle, in a rectangle, we know that all diagonals are congruent. So we know that all diagonals are congruent. So we know diagonals are congruent, and we know that the diagonals of rectangles bisect one another. They are going to intersect and cut those into two equal parts. So if we know the diagonals are congruent and we know LN, well, LN has to be equal to MO because diagonals are congruent. We know the length of NL or LN is 26, so that means MO must be 26. So the length, the segment, the length of MO has to be 26. So we answered one part of our question. The second part asks us to find the length of MZ. So the length from here to here, MZ. So if the entire length is 26, well, we know then that MZ has to be, MZ, I meant to say, not MN. MZ has to be half the length of the entire diagonal, MO. So we know MO is 26, so if we take half of 26, that's going to give us the length of MZ. And what is half of 26? If you said 13, you are correct. So the length of MZ is going to be equal to 13. So we just solved this problem completely using the properties of one of our newly learned about special parallelograms, and that is the rectangle. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. So I'm going to save getting acquainted with some of the other special parallelograms for you to get a little bit more acquainted with them. Leave that for the lessons in Schoology, and you will learn more about all the properties of all the different types of parallelograms in the lessons this week. But let's stop now and complete the key phrase assignment. So remember, this is how you get your credit for watching the recording and get your points. I've got 2 questions that I need for you to answer. The first one, I've got a figure. And I want you to tell me, what do the arrows mean in the figure below? What do those arrows tell you about those sides? And then one of the special parallelograms that we learned a little bit about today was a rectangle. Name a property, just one property of a rectangle. And that's it. Have a fantastic rest of your week and let me know if you have any questions.